Well, all right. Hello, students of math. This is Applications Part 3, and we're going to look at work type of problems. Now, before we dive into an example, let me just explain how this kind of works. Let's say it took you something like 30 minutes to mow the lawn. How much of the job would you get done in 1 minute? So if I said to you, in 1 minute, what fraction of the lawn would you have mowed? Well, if it takes you 30 minutes to mow the whole lawn, then in 1 minute you would have mowed 1/30th of the lawn, right? Or in 2 minutes you would have mowed 2/30ths of the lawn, and so on, okay? So that's kind of the approach we're going to look at. We're actually going to try to set things up and say, well, in 1 minute, here's how much of the job you would get done. So let me clear the screen here, and I'm going to give you the details for a specific example. Okay, so we have two guys, and let's say they can mow the lawn. So say there's Ken, and Ken needs 40 minutes if he works alone. 40 minutes to mow the lawn. To mow the lawn. Okay, and then we have Joe helping Ken out. So Ken and Joe both mowing wildly. So Ken and Joe need 24 minutes to mow the same lawn. Okay. All right. So now the question is, how long for Joe to do it by himself? How long for Joe to mow alone? Okay, so that's the question. So how do we deal with this? Okay, so here's what you do. You think of the lawn as the job. Okay, now how much does Ken do in 1 minute? So you set it up in 1 minute. Let's just figure out how much of the job Ken contributes, I guess, is a way of thinking of it. So in 1 minute, he gets 1/40th of that lawn mowed. And that's because it takes him 40 minutes to do the whole lawn. Okay, so there's Ken's part. Okay, now what about Joe? Well, I don't know how long Joe needs to mow the lawn. So I'm just going to say that he needs X minutes. So we're going to say X minutes for Joe. So in 1 minute, this is the fraction that he completes. He completes 1/x of the lawn. Think of it this way. If Joe needs 50 minutes, then he gets 1/50th of the lawn mowed in a minute. If he needs 20 minutes, he gets 1/20th of the lawn. Okay, so here's Ken's contribution, and here's Joe's contribution, and together they need 24 minutes. So how much of that lawn, what fraction of the lawn would they have mowed in 1 minute, working together? 1/24th. Okay? Now, believe it or not, we've just created our equation. So what I'm going to do now is solve the equations. This isn't too bad a question, really. So I'm going to multiply this by something that's divisible by 40 and 24 and x. So 40 and 24 and x. There's probably a smaller number, but you know what? I might spend 10 minutes looking for it, so I'm just going to use 40 and 24 and x. So the first term here, the 40s would cancel, and I'd be left with the 24 and the x. Okay, so there's that, plus. And then the second term here, the x's cancel, and I'm left with 40 times 24, which I'll do at the next step. And then on the right, the 24's cancel, and I'm left with 40 and x. Okay, so let's move all the x's to one side. So I'm going to subtract 24 x's. And that leaves me with 16 x's over here. And over on this side, 40 times 24, well, I worked that out. It's 916. So all I got to do now is divide by 16, and guess what? It takes Joe 60 minutes. He's not the speediest guy, but at least he helps. And guess what? That's the end of this little word problem. So that wasn't as painful as the last one. So that's kind of nice. So I'm going to shut down. We'll talk to you in a little while.